Lesson 23B, Proportions Day number 1. Proportions we kind of talked about at the end of yesterday's lesson, so today we're going to fully go into that, solving proportions and word problems involving proportions, and explaining the process of how to solve proportions. Proportions are made up of ratios, which is what we've been working with for the past few days, and you're learning about proportions because let's say you want to change a recipe to serve more people or serve less people. You need to make sure that recipe stays proportional, otherwise you're going to have too much sugar in it or not enough flour. It's going to taste funny. It's not going to turn out very well. Alright, so that's a classic example of when you would use proportions in real life. So background knowledge, we talked about ratios. How do we simplify ratios? Do we reduce or divide? Reduce. So if I reduce this ratio, what would it be? 8/7. Do I make it a mixed number?
No.
No, because a ratio has how many numbers in it? 2. It's a comparison of two numbers. If I make it a mixed number, it's no longer two numbers. Here's another example. 6 cups of flour to every 9 eggs. If I write that as a ratio, I can get rid of the units. And again, you can write it with a colon or as a fraction. Equivalent ratios is the first thing on your notes today. That is a set of ratios that are of equal value, meaning when you reduce those fractions, they are equal to each other. They have the same fraction. Here are some examples. If I have the fraction 2/3, go ahead and write this down, and I multiply 2/3 by 2, I would get 4/6, right? And that's equal. If I multiply 2/3 by 3, I'd get 6/9. And that's still equal, right? If I multiply 2/3 by 4, that would be 8/12. Still equal, right? Who can tell me why these three fractions are all equal to 2/3? Who can tell me why? Hunter. Not that it goes in order. Ashley? Exactly. That's a perfect answer. You can reduce all three of those fractions all the way down, and it'd all be 2/3, right? Your list would look like 2/3, 2/3, 2/3, 2/3. Yes? Here's another example. If I have 28/16, that is equal to 21/12, and it's also equivalent to 14/8 and 7/4 because these three fractions here all reduce down to equal what? 7/4. So what I want you to do with these two fractions is reduce both of them and see if they're equivalent. See if you get the same fraction. Good. Both of them reduce down to 4/5. They're both 4/5, so I can put an equal sign in the middle of them and say 4/5 equals 4/5, meaning, yes, they are equivalent. Here's some more for you to practice with. Do number 1, 2, 3, and 4. Go ahead and reduce those fractions and see if those two are equivalent. If they are, put an equal sign in between them and say yes. If they're not, put a not equal symbol in between them and say no, they are not equivalent. Number 1, they reduce to what? 2/3, both of them?
Yeah.
Good. 2/3 equals 2/3, so I'm going to put yes, they are equivalent. Number 2, what do those fractions reduce down to? Zach?
12/7.
Good. 12/7 is already reduced, and then this one becomes 30/17. Are those the same fraction? So are they equivalent? Nope. I'm going to put a not equal symbol in between and then say no. Now number 3, what do those ratios reduce to?
8/11, 365, and 622.
Are they equivalent? Nope. And last one, what do they reduce to? Go ahead. Okay, and the other one? both of them. So they are equivalent. Now I want you to write this in the box on your notes. A proportion is an equality between two ratios. In other words, when you take two ratios and you reduce them both down all the way, they are the same fraction. A proportion is an equality, they are equal between two ratios. So now look back at number 1. We said they were equivalent, so now tell me this. Is it a proportion? Yes or no? Yes, because they're equal. Is number 2 a proportion? No. Is number 3 a proportion?
No.
How about number 4?
Yeah.
Good. Okay, look at number 5. On your notes, I did not finish typing the problem out for you, so please look up there and write it down. And the goal of this one is to solve for n. We want to figure out a fraction that is equivalent to 5/3, where the bottom number is 21. So there's 2 ways to do this. I don't care which one you choose, as long as you show work. Okay, I'm going to show you both. Here's the scaling method. First, you start with, 5/3, and then you scale up. Times 2 would be 10 over 6. Times 3 would be 15 over 9. 5/3 times 4 would be 20 over 12. And I have to keep going until the bottom number is 21. Can I stop now?
Yeah.
Good. So 5/3 equals 35 over 21, which means n equals what? 35. That's one way to do it. The second way to do it is to realize that 3 times 7 gives me 21. So the top number also has to multiply by 7, which gives me 35. If you want to do the scaling method, this is your work on your homework. If you want to do the other method, your work needs to have this part. So again, your problem looks like this. 5/3 equals n over 21. Your work needs to look like this. Okay. If you just write n equals 35, it looks like you're not showing work and you copied somebody's answer. I need to see your times 7 times 7. Are we clear? Okay, go ahead and do number 6. You can scale up or you can multiply. So here is the scaling up method. Start with 3/7 and scale up until the top number is a 12. So what does n equal? 28. Or you can see that 3 times 4 is 12, so 7 times 4 gives me my 28. Go ahead and do number 7. Who did the scaling method? All right, so everyone did the multiplication method. What did you multiply by?
5.
Good. So scaling up looks like this. You end up with 25. Or times 5 on top and bottom, you get n equals 25. Here's number 8. Scaling up looks like this. 9 over 2 scales up until the bottom's a 12. And I get n equals 54. Or 2 times 6 is 12, so 9 times 6 is 54. Any questions so far? Pretty good, right? Okay, number 9 is a little bit different. Notice the left fraction is now the bigger one. So far we've been having the small one on the left, and then it gets bigger, right? Here is how you would do this with the scaling method. You would start with my 12 over 20, and then reduce it all the way down, which is 3/5. And then it looks like the kind of problem we've been doing, where this 3/5 is now smaller than the 6 over n, and you can scale back up until the top number is 6. Or you can see that it's getting smaller, right? So instead of scaling, what can you do? Divide. Good. Getting smaller would be divide. Getting bigger means you're multiplying. So this would be divide by 2 to get n equals 10. Make sense? Go ahead and do number 10. Scaling all the way down gives you 9 over 4, and then scaling back up until the bottom is a 16 gives you 36. Or 32 divided by what is 16? Divide by 2, so the top and bottom both have to divide by 2 to get 36. Here's number 11. scaling looks like this, all the way down, then back up, or divide by 6. Last one here. Scaling down, you would get 4 over 19, and then scale back up until the bottom's a 38, or figure out that it divides by 3 and equals 8. That's very smart. Very good. All right, on the bottom of your notes there, we have some word problems. It's a word problem, meaning your answer needs to look like a what? Sentence. Make sure it's a sentence. Here we have, set up a proportion and then solve. So you need to set it up. Don't just give me an answer. This first part, a recipe for 26 rolls calls for 5 tablespoons of butter. We are comparing two numbers here, right? What's that called again? A what? A ratio. Let's write that ratio down. 26 rolls compared to 5 tablespoons. And then the second half of the problem gives you the other ratio. We're setting up a proportion, so it has to be equal. And since it's equal, I need to keep it same word with same word. Which one's on top right now? The rolls are on top. So here my 78 rolls needs to be on top. And then N on the bottom. Because, let's say I have, here's an example, 2/3 equals, times 2 would be 4, 6. That's true right now, right? If I write it upside down and twisted, it looks like this. Is that true? 2/3 equals 6/4? No, that's not true. I can't twist my proportion. So if I have rolls on top, make sure you have rolls on top for the other one too. Go ahead and solve this proportion. Good. Scaling up looks like this, if you prefer that. Or times 3 gives you 15. But I need a sentence. What would that look like? Does it say solve for n, or does it say how many tablespoons are needed? Good. 15 tablespoons are needed. Please answer the question. Go ahead and do number 14 with me. Again, we have this ratio. So I'm going to write this ratio equals this ratio. So 16 cups is on top for 36 brownies equals, what's on top? 8 cups. And then n number of brownies. Go ahead and solve this proportion. Scaling down and then back up looks like this. Or, what would you divide by? Good. Divide by 2 and you get 18 brownies can be made. Go ahead and finish the rest of the notes, number 15 and 16. Navreen, what did you get for 15? Good. Set up as boxes on top and boxes on top. Solve by scaling up or multiplying by 5 to get 30 boxes. Number 16. Gustavo?
You can make 27 cookies with 3 cups.
Good. Set up proportion 12 over 108 equals 3 over n. Scale down, then back up, or divide by 4. Any questions about today's lesson? All right, number 1, you're going to speak first what you learned today. Ready? Share.